Hello, grade 8 learner. Welcome again to another mathematics lesson. In this video lesson, we will discuss how to solve problems based on the theorems on angles formed by parallel lines cut by a transversal. This is based on the K-12 curriculum learning competency. The learner proves properties of parallel lines cut by a transversal. It's another great day to learn, so grab your pen, paper, and module as you watch and learn from this video lesson. Refer to your quarter 4 math module entitled Parallelism and Perpendicularity for this lesson. For this example, we are given that line A is parallel to line B. The measure of angle 1 is 3x minus 8. The measure of angle 2 is 2y plus 3. And the measure of angle 3 is x plus 6. We are going to solve for the values of x and y. We begin by observing the figure and identifying the angles that are given in the problem. Locating and classifying the angles correctly will be helpful in our solution of the problem. Let us process what we know. Let us identify the angles that are given in the problem. We see that angle 1 and angle 3 are non-adjacent exterior and interior angles that lie on the same side of the transversal. So we say that they are corresponding angles. Based on the corresponding angles postulate, we can also say that angles 1 and 3 are congruent to each other. Angles 2 and 3, on the other hand, are interior angles lying on the same side of the transversal. Thus, we can say that they are same-side interior angles. Based on the same-side interior angles theorem, we can also say that angles 2 and 3 are supplementary to each other. Take note of this as we look at the solution of the problem. Let us solve. Let us work on what we've learned about angles 1 and 3. Since they are corresponding angles, they are also congruent to each other, which also means that their measures are equal. We write that idea as an equation. Thus, the measure of angle 1 is equal to the measure of angle 3. From that equation, we are going to substitute the given measures of angle 1, which is 3x minus 8, and angle 3, which is x plus 6. To start solving for x, we then transpose x from x plus 6 to the other side of the equation, so that we can keep all terms with the variable x on the left side of the equation. We also transpose negative 8 from 3x minus 8 to the other side to keep all constant terms on the right side of the equation. Then, we simplify the resulting equation by doing the operations. 3x minus x results to 2x, while 6 plus 8 is equal to 14. From the simplified expression, 2x equal to 14, we then divide both sides of the equation by 2 to eliminate 2 from 2x, so that we can get the final answer, which is x equal to 7. Next, we solve for y by working on what we've learned about angles 2 and 3. Since angles 2 and 3 are same-side interior angles, this means that angles 2 and 3 are supplementary to each other. We write that idea as the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees, or simply 180. We then substitute the given measures of angle 2 and angle 3, which are 2y plus 3 and x plus 6. Since we know already that the value of x is 7, we then substitute 7 for x in the equation. We simplify this expression by adding the constant terms 3, 7, and 6 to get the resulting equation 2y plus 16 equal to 180. We then transpose 16 to the right side of the equation to keep all constant terms on the right side of the equation and all those with a variable y on the left side of the equation. We simplify the resulting equation to get 2y equal to 164. We then simplify both sides by 2 to eliminate 2 from 2y to get the final answer, which is y equal to 82. We now state our conclusions. Given the figure and the following statements, we solved and learned that the value of x is 7, while the value of y is 82. Congratulations for finishing this video lesson. Now apply what you've learned by answering the activities in the activity sheet. Happy learning! We'll see you again in our next video lesson.